Okay, look at number 18. Show with a sketch or some other method that the equation 2 cos x equal to x squared has one positive root alpha, and show that alpha is greater than pi upon 4 but smaller than pi upon 3. So this is what we are going to show. So look at here, I have already prepared the solution. Okay, so here we just write as usual. Then we look at the two sketch graph. One is y equal to 2 cos x, the other y equal to x squared. The cosine graph is like this. This is the blue color one, from 0 to pi upon 2. Okay, the amplitude is 2 for cosine graph, and then this is the parabola. Okay, minimum parabola, and then you see that the two curves, they intersect at one point. Therefore, the two curves, you see, the two curves y equal to this and this intersect at one point where x equal to 0. Therefore, obvious x is greater than 0. Therefore, the equation given has one positive root. That means they cut at one point only where x is positive. Okay, then we are going to show that the root is between pi upon 4 and pi upon 3. Is it between pi upon 4 and pi upon 3? So same methods. What we do here, we write it as a function. That means we look it as a function, and then I substitute this one, x equal to pi upon 4. I use calculator, I will get 0.797. That means I will get positive. And then when I substitute this one, I will get negative. So because the size changes, that means if I want to get fx equal to 0, it must be between this one. Because one negative and one positive, that means there must be a 0 in between. Therefore, the x is between here also. Therefore, since this one has opposite sign, therefore the equation has a root between this one and this one. Okay? Okay, now we go to the next part. Right? I mean, the question is the same, nothing special. Okay, here, use 1 as the first approximation. That means your x1 is 1. Okay, find a successive approximation of the root alpha. That means we are asked to find x2, x3, x4 and so on using Newton-Raphson method, and this process must be carried on until 2 successive iterations. Okay, 2 repetition are the same after being rounded to 3 decimal places. So that means you are asked to every time you calculate, but when you calculate, when you use the formula to calculate, since they want 3 decimal, you must use 4 decimal to calculate, because we every time must have 1 extra for the purpose of round up. Okay, because we have to round up. Remember that you cannot, when you do the calculation, you cannot use 3 decimal. You must always have 1 extra or 2 extra. Minimum is 1 extra. That means you have to use 4 decimal, or you can use 5. Okay, so here every time after you calculate, you round up to 3 decimal, and then if the 2 answer is the same, then you stop. Here they will tell you when to stop. So look at here. So what we do now, we are going to do this. Therefore, okay, this is your fx. Then after that, we differentiate f prime, okay, and then according to Newton-Raphson, okay, everybody know already, your x2 is equal to x1 minus f x1 over f prime x1. So I just substitute. So when I substitute, I will get all this. Okay, then I use a calculator. Here, the 1 I substitute into the f. Okay, that is, I substitute inside here, and this, the bottom one, I substitute inside here. So that's why I get 1.029, and then here they ask us to round up to 3 decimal. I will get 1.022. So when you compare, the first answer is 1.00, isn't it? So of course 1.00 and 1.022, of course 1.022 is a better answer. Okay, that means we have already improved the accuracy. Okay, then we go to x3. x3 we substitute here. So you see, I substitute, I use 4 decimal. I use 4 decimal. I use 4 decimal. But the question asks for 3 decimal because I have to make 1 extra for round up purpose. And then here I use a calculator. I press the calculator. I get this, and then I will get. Then I round up to 3 decimal. I have 1.022. So now you compare this one and this one. You see that for 3 decimal places, this is already the best because there is no improvement. the answer is the same. That means the answer is 1.022. But let's say the question asks for 4 decimal places, that means you still cannot stop. Why? Because here 4 decimal, you have 0.219, 0.216. Of course, 0.216 is better than 0.219. So we have to still continue to see whether we can have even a better than this one or not. That's why we still have to continue. But because we are asked for 3 decimal, then we stop here. And this is how the question asks us to stop. Okay, the question says every time you round up to 3 decimal, if the 3 decimal is the same, then you stop. Okay, so after this, the following one I will show you where the question never tell you when to stop, and I will explain to you when to stop. Okay.